Okay, so let's set up some fake data here to play around with just so we can kind of see how this works. Let's say we have two variables. Our x variable will be the amount or the number of hours that you spend in a week playing video games. Okay, so that'll be our x variable. And then, so that's video games, video game playing. And then we'll have the y variable will be your GPA at the end of the semester. Okay, so we'll check out your grades and see if it's related to how much of the video games that you're playing. Okay? Okay, so now we have our data. We have all of these video game hours here, and then we have the associated GPA for that particular person. Okay? All right, so we've got a lot going on here. Let's do a little bit of calculating. The first thing that we need to do is just establish a sort of reference point so we can see where they're varying from. All right, so we could use 0 or we could use lots of different things, but we'll use the mean because it turns out that that makes things computationally easier for us later on. So let's go ahead and calculate the mean of each one of these variables. X bar equals, in this case, it's 10.4. Okay, so there's 10 cases, so the sum of the cases was 104, and I just divide by 10. All right, and then over here, we'll do the same thing, y bar, and that turns out to be 2.88. And again, the sum of that, since I have 10 cases, it was just 28.8. All right, so now we've got something to compare them to. Where are they varying from? We're going to use the mean. All right, so to find out how they vary from each other, all I need to do is just subtract them. And so I'll figure out how far away from their mean they are. And so we're back to something that we've done a lot here, is subtracting the particular instance of the variable from its mean, or subtracting the mean from the instance of the variable, actually. Okay, so xi minus x bar. So let me go ahead and just take a second and do that. And then I'm going to do the same thing with the y's. So I'll have y sub I minus the mean of y over here. And so then I'm just going to be subtracting each one of these from their mean. Okay, we have the data. So now what we're looking for here is the pattern of covariation. What does that mean? What would we see if these things would covary? Well, it's not that they're the same as each other. We don't need this to be negative and this to be negative. What we need to see is the same sort of pattern across each pair. So as we go down through the data. So for example, we have up here, we have a negative and we have a positive. So if we have a lot of those, negative, positive, we're going to have high covariation. So this one and this one are both going to contribute to covariation. On the other hand, these two cases, this second case and this third case, are going to offset each other because these ones are moving together and these ones are moving differently from each other. And so those two are going to sort of cancel each other out and reduce the covariation. If everything were positive going down, we'd have high covariation. If everything is negative positive, we'll have high covariation if all of them are like that. So the more consistent they are from case to case, the higher the covariation will be. We'll show you how that works in just a second here when we get to the calculation part. To represent that idea mathematically in the calculation, all I'm going to do is multiply these two things together. So if I have negative and negative, I'm going to get a negative. And so if I keep getting negatives all the way down, I'm going to get a big number when I add it up. If I get positives, so if I have a negative and a positive, that's either one of those multiplications is going to give me a positive number over here. And so that's, if they're all like that, then I'm going to get a high covariation. Okay? If they're different from each other, they're all mixed up, which is kind of the way this one is, that's going to detract from the covariation. You're going to see how that works. So the next thing I need to do is just multiply these two columns together. Okay, so I've calculated the product of these two different numbers here. And so now we can kind of get a sense of this covariation notion. So if they were all covarying in the same way, all of these numbers would be positive or all of them would be negative, okay? But they're not. Some of them are positive and some are negative. So we're going to have some things that sort of contribute to the covariation and some things that don't. And what we're going to do is add them all up, and you can see if there's no covariation that they would it would get us somewhere near 0 because they would cancel each other out. We'd have some negative things that are going one direction, and we'd have some positive things that are going the other direction, and we'd end up with a small number because they would cancel each other out. And that's the notion of covariation, okay? So if you, just as a little sort of backward thinking exercise, we didn't start with the formula today, but we could kind of build up the formula from this concept of covariation. So what did we do? We had this thing right here times, whoops, it's supposed to be y minus y. And then what did we do? We added them up, right? And so that's the principle of covariation. We did it from, I equals 1 to n, right? We went through every single one of our cases, in this case 10. We added them up, and that gives us negative 25.7, okay? That's covariation. We have a way of calculating that number. Okay, so I added them all up, and I have a number here. But if we think about it for a minute, you'll realize that the size of this number is going to be determined a lot by how many cases I have, because I'm just adding things up across these cases. And so it may, if I had a lot more cases with the same amount of covarying going on, I'd have a higher number. And so I need to adjust for how many cases I have, because I want to kind of compare these across something with 10 cases and something with 1,000 cases. I'm going to get a different number. So I need to adjust. So my final formula for covariation is just this divided by n. Ta-da! That's covariation. All right, so to get my final number with my data set, I just need to divide this by 10 because I have 10 cases. And so negative 2.57 is the covariation. What does that mean? Well, the most important thing here is that there's a negative relationship. That means as one number goes up, the other one is going to go down. And if you think about that, that makes intuitive sense with our data, because we expect that the higher the number of hours you spend playing video games is, the lower your grades are going to be. And so there's going to be a relationship between the data that looks something like this, where we have the video games down here, and then we have the GPA, dependent variable, up here. And we're going to think that the higher the amount of video games is, the lower the GPA is. So the data is going to look something like this, and the line's going to be something like that. Okay? Those things still have good covariation, even though it's a negative number. Okay? And that's what we would expect. You spend a lot of time playing video games, you're not studying, your grades suffer.